Hey guys, I am Gautam and welcome to GMX. In this video, I am going to talk about the basic Reimer-Tieman reaction and what will be the reaction conditions, what are the reaction mechanism for this reaction, and what will be the reactant and product, how do we get the product from the reactant, these kind of things I am going to talk about that. Okay, so what is Reimer-Tieman reaction? Basic Reimer-Tieman reactions, that is about when phenol, this kind of hydroxy group on the benzene ring, okay, the phenol reacts with this is chloroform CaCl3, that is chloroform, and along with base, that is NaOH, or you can use KOH. Okay, you can use also here KOH. So when this reaction NaOH or KOH, this base is reacted, when this is the reagent, this is the base, another reagent, and along with the heat. So what we get? We get the CH group in the ortho position of the phenol, that is called salicylic. Okay, so phenol to salicylic, how do we get this product salicylic from phenol? This is all about the Reimer-Tieman reaction. Okay, so let's talk about the reaction mechanism. How do we get this product from phenol? Okay, so this is a very common reaction and this is very important for NET, GATE and IIT JAM examination. Okay, so after discussing the mechanism, I will be talking about if chloroform is replaced by methyl, say carbon tetrachloride, then what will happen, what will be the final product. Okay, so I will be discussing that. So first let's talk about the reaction mechanism of this Reimer-Tieman reaction. So here this is chloroform. Okay, so when it is treated with base means NaOH, so or KOH, that is the source of OH minus, strong base. So this negative charge will take this proton. Why? Because this, you know that from a system a proton obstructs, that means that proton should be acidic, and here this proton is acidic. Why acidic? Because I am showing you why it's acidic. So after taking this base, what product will be obtained? Okay, this product will be obtained, chlorine. Okay, so why it's stable? Because it's resonance stabilized, because you know chlorine has vacant d orbital, so this kind of resonance can be occurred. C double bond C, Cl, okay, and one negative charge over here. Okay, so this another two structure with this bond and this bond you will get. Okay, another two structure. Okay, so I am not discussing about the two structure, I am just talking about this two structure, this structure. So it's a resonance stabilized thing. Okay, so now let's talk about, as it's resonance stabilized, so to form this compound, this hydrogen will be abstracted, okay, by this base. Okay, that's why it's acidic. Okay, so we can say this compound as acidic because of the stability of the, because considering the stability of the conjugate base. So it's a acid, so it will be the conjugate base. Okay, so conjugate base is stable, that means this is acidic, this proton is acidic proton. Okay, so now after forming this is a stable compound. So now here on the carbon, it's the negative charge, so carbon is electropositive element, so it's the negative charge on it, it's not suitable. So what will happen in the next step, I am not showing this arrow right now. Okay, so I am not showing this one. So in the next step what will happen, one of the chlorine group will be abstracted to make this negative charge neutral. So what we get, so minus Cl minus, and the product will be obtained, that is C to Cl, and no negative charge over here, that is. So what is this called? This is very important. You can face one question regarding this, that what is the intermediate in the Reimer-Tieman reaction? That is, of course, it's a carbene. So what is the name of this carbene? That is dichlorocarbene. Okay, dichlorocarbene. So it's a carbene, that's the intermediate. Okay, so after generating this intermediate, phenol will react with this intermediate, and then finally we will get the product. So how phenol will react with this intermediate? Let's see. Okay, now let's talk about this phenol. So phenol, this is, we can write this in this way, and the carbene, dichlorocarbene, that is generated like this. So this is dichlorocarbene, this is phenol. When these two reacts, the product we get like this. So first phenol reacts with KOH or NaOH. NaOH, that is the source of OH minus. Okay, so these OH minus will take this proton and one negative charge will be formed on that oxygen atom. So the product will be here like this. Okay, so this is resonance stabilized again. So here it will be like this, and there negative charge, then this will be on this bond, and there will be another negative charge. So this is the resonance stabilized. This is called phenoxide ion. Okay, so after this dichlorocarbene will come and this kind of reaction will occur. Okay, so the intermediate will be like this, 1 2, here will be keto group, here it's a hydrogen and it's Cl, and this, for this 2 electron there will be one negative charge. Okay, so now what will happen, this negative charge will take this proton, okay, and this bond will be on here, and then the negative charge will be formed on the oxygen atom. Okay, so in the next step what will happen, the product will be like this, that here pi bond, here it's OH minus, here it's C, and here one hydrogen that is that is accepted by this negative charge, and here chlorine, and here another chlorine. Okay, so this is the reaction intermediate over here. So in the next step what will happen, this OH minus, this negative charge can be generated, can be used, can be protonated by one hydrogen atom. How? To make this OH, O minus to OH, first the base KOH, that is the source of OH minus, will attack to this center, and Cl, it's a halogen, so it's an electronegative atom, so it's a very good leaving group. So one Cl atom will leave the system, and then what will form, the product will be, here it's the 3 pi bond is over here, so it's a negative charge, then here it's one OH, one Cl, and another H. Okay, so I am writing these OH like that. Okay, so in the next step what will happen, this minus will take up this proton, and this kind of negative charge will be formed on this oxygen. Okay, and finally that negative charge will be on this bond, and there will be one double bond over here, and this Cl will, it's a leaving group like the previous one, so this Cl will leave the system, and here will be a double bond system. So what will be the product? So the product will be like this. Okay, so the product will be like this, that this is the benzene ring, this is one OH, that is this minus will take up this proton, and this will be OH, and here there will be double bond, and there will be hydrogen, so C double bond O and hydrogen. Okay, so this is what is this compound is named, this compound is called the salicylaldehyde. Salicylaldehyde. Okay, bas. So this is the overall reaction mechanism of this reaction. Okay, so this is the whole Reimer-Tieman reaction and the whole mechanism how we get the product from phenol to salicylaldehyde. Okay, so this is all about the basic reaction mechanism of this one. So here it's one more important thing is that why I am considering only ortho product. You can consider also the para product because it's a negative charge, that is this is a phenoxide ion. So here this is the ortho para directing group. So this is ortho, this is para. The one product we get in the para position also, but the ortho product here will be the major product. Why? The question comes why? Why the ortho product will be the major product? That I am going to discuss now. Because you know that I am drawing this structure. So it's O, it's H, and it's C, then it's O, and this is H. So here hydrogen bonding is possible. Okay. So because of this hydrogen bonding, this product is stable. Okay. So whatever ortho product is formed, that is going to be very, very stable because of this hydrogen bonding. That's why ortho product here it's the major product. Okay. And finally we get the ortho product, major product, and of course we get the para product, but that is the minor product, that is OH and CHO. Okay, so that is the minor product. So major, this is major, the ortho product, this is minor. This is very important because in IIT JAM, NET or GATE examination, you may face they will ask what will be the major product. So you may think that their repulsion is of course very, very less than this one, but here you have to consider the hydrogen bonding. That is going to be very, very important over here. Okay, because of this stability, 6-member cyclic ring, that is very, very stable. Okay, but here no such ring formation is occurring. That's why the major product will be the ortho product. Okay, so now whatever I have said in the previous part of this video, that what happens if we consider the carbon tetrachloride. Okay, if instead of the chloroform, what will be the final product? So let's talk about that. What will be the product if we consider the carbon tetrachloride? So instead of chloroform, if we consider carbon tetrachloride, okay, so what will happen? So then say here it's a CCl4 carbon tetrachloride and the base NaOH, and along with the heat, the other reaction conditions are the same. So what will happen? So now the product will be formed, that is from if we consider this is phenol, this is chloroform, and in presence of NaOH base, what will be the product? The product is this is OH, the major. I am considering only major product. This is CHO. Okay, so remember, if we consider CCl4, then we will not get the same product. Slightly different product we will get. So what will be the product? The major product will be the ortho product, but the final product will be the like this, COOH. Of course, after taking HCl, that is slightly acidic medium, because instead of if acidic medium is not present in the final reaction mechanism, then this kind of product we will get, that this is O minus Na plus, and this is COO minus Na plus. So to make these two negative charges protonized, so we need to take the acidic medium in the final step only. Okay, but before this, if we consider CCl4, then the product we will get this one or this one, whatever you want to consider. Okay, so this is all about the basic Reimer-Tieman reaction. And if you may think that if para position is blocked, then also of course if suppose here one group is present, so then in the case also of course you will get the ortho product in the major amount. If ortho product is blocked, then you will get slightly greater amount the para product. Okay, like that. So this is the basic other things like that, but those are not that much. Those you can easily understand whatever you have understand in this mechanism, but believe me, this reaction mechanism, the basic reaction mechanism you should remember, and the important thing is about the intermediate. So you just have to remember the intermediate. What is the intermediate in this reaction? Okay, because usually they ask about the intermediate from this reaction. What is the intermediate in the Reimer-Tieman reaction? They will give the different options. It's a carbocation, carbon ion, then radical or carbene. So the right answer will be the carbene. The name is dichlorocarbene for this case, for the real Reimer-Tieman reaction. Okay, so that is all about the Reimer-Tieman reaction. And if you have any query, regarding this, you can ask in the comment below, and you can ask in the Facebook group. Okay, that will you will get the link in the description below. Okay, so thanks for watching.